Hey guys, welcome back to the channel. Today we will be discussing how to find the middle node of the linked list. So the problem statement says that given a non-empty singly linked list with head node, return a middle node of the linked list, and if there are two middle nodes, then return the second middle node. Now let's try and understand with example. Now there can be two cases, one when n is odd. Then there will be only one middle node, and that will be the node with the value 3 in this question. In this example. But when n is even, there will be two middle nodes. Here, both node 3 and 4 are middle nodes. But as per the problem, we will return the second middle node, that is the node with the value 4. Now let's see how we will solve this. So we will be given with the head node of the linked list. One way to solve this problem would be to find the count of all nodes in the linked list. So here, let's say k will be the size of the linked list. Then the middle element will be k by 2 plus 1th node. Here, k is equals to 5. Thus k by 2 plus 1 becomes 3, that is, the middle node will be the third node of the linked list. Now let's look at another example when n is even. Here k will be 6, and therefore k by 2 plus 1 will be 4. Thus the middle node will be the fourth node. Now in this approach, we are using two traversals. The first one for getting the size of the list, that is k, and the next one for reaching up to the middle node, that is reaching to the k by 2 plus 1th node. But there is another approach where we can find the middle node in single traversal. And in an interview, it is better to come up with the most optimal approach. So let's see how we will solve this in single traversal. So we will be solving it with the help of slow and fast pointer technique. So we take two pointers, slow and fast, both pointing to head at first. Now the difference between the slow and fast pointer is that slow pointer makes one step at a time, while the fast pointer makes two steps. The idea behind doing this is that when the fast pointer will reach at the end, the slow pointer will automatically be at the middle of the list, and we can return slow pointer as the answer. Now let's understand with this example. So at first, both pointers are pointing to head. In the next step, fast pointer moves to 3 while slow is at 2. Again, fast moves to 5 while slow is at 3. Now fast cannot move 2 steps further, so we will stop here, and thus we see that slow is automatically at the middle node. Here we will return slow as the answer. Now let's look at the code. So we will be given with the head node of the linked list. So at first we declare two pointers, slow and fast, and making them point at head first. Now for the while loop, this will be the terminating condition. Whenever the fast pointer or the next of the fast pointer reaches null, means we have reached the end of the linked list. Note that we have to check for fast next also, because we are using it in assignment operation. Otherwise we will face runtime error. Now in the while loop, the slow pointer takes one step, while the fast pointer takes 2 steps at a time. And when the while loop will terminate, we will return slow, as we have got the middle node of the linked list. Now let's try and run with this example. Here n is even. At first, neither fast is null nor fast next is null. So we will enter the loop, and the slow moves one step while fast makes 2 steps. This loop will work again, and now fast comes to 5 while slow is at 3. Here again both fast and fast next are available. So the loop will work one more time, and now fast is at null and slow is at 4. Now because fast is null, the loop will break, and we will return slow as the answer, that is the node with the value 4. Now the time complexity to solve this problem is O of n, because we are using a single traversal, and the space complexity is O of 1 because we are using constant space. So this was all about the problem. If any doubts or suggestion, please write in the comment. Thank you for watching. Do like, share and subscribe to the channel for more such videos.